So like alpha erosion is a better way to make something disappear instead of fading out. You could also check this page to kind of understand it a bit better if you want to go like full from start. And here's something about erosion effect, which is subtract. Basically this is basic stuff, but this is how it looks when using something like erosion, which is just making it lower and lower. Instead of doing basic fade out, you could see how it disappears. So I'll quickly show what it means. So for a quick fundamental stuff, I'll use Photopea. You could use Photoshop too, but this is just for fundamental, so it's not needed basically. And what I'm going to do is, if I create something like a gradient, so if I create something like a solid layer, you could see that this is fully black, which is 0. This is fully white, which is 100, which is basically 1. So 0 to 1. Middle would be like 0.5, like this. So 0.2, 0.8, something like this. So 0 would always be black, 1 would always be white. Anything below this one would be minus stuff. Anything above this would be more. Now if I make this fully white and then create a new layer, this is 1, right? Because it's fully white, so it's 1. I'll set this to subtract like this, and in here I'll use my brush. Okay, so if I use the brush and say that I want to use 50, which is 0.5, this is set to subtract. Okay, so whatever it is, it will subtract this one. You could see how this looks. So this is going to be same color as this one because it's doing 0.1 minus 0.5, which is 0.5. But if I make something, let's say 1.1, and then add it in here, you could see it doesn't look same because we are doing 1 minus 0.1, that is 0.9. So this color is 0.9 basically. You could see 0.9 because we did 1 minus 0.1. Similarly, if you do something, let's say 0.8 or 0.7, and then add it in here, and now if I check this, it is 30 because 1 minus 0.7. So 1, we are subtracting this value, like these values. So with this subtraction, we can actually use these values, which is 0 to 1, to kind of fade it out. For example, if I now do something like filter, render clouds, I just created this clouds, which would look like this normally. See, this don't look good. Let me make another one. I have to reset this, I forgot. So let's say if I make this one have clouds, so render clouds, and then make this to subtract. You'll see how this looks. It looks different because it is doing 1 minus whatever these values are. So it means that if I paint here fully black, which is this one, sorry, fully white, I mean, it will turn to black because we are doing 1 minus 1, which is black. You could see even though I'm painting white, it's turning to black because 1 minus 1 is 0, and that is basically black. So that is the main fundamental for the erosion. So if I create a new material, let's use a plane because that's a better way to see. I'll turn this into an unlit model. It doesn't matter, it's your choice what to do. And here if I connect this as a white color, which is like 1, you could see the value is 1, which is same as, so you could see it says 1, 0 would be black. If I add a subtract node, it's going to look black because we are taking this and subtracting 1. So if I subtract 0.5, it would look 0.5. I'm removing post-processing just to see, but when you are doing some changes, you should keep it enabled. This one basically gives an unlit kind of effect. So like 0.1 would be this one, 0.8 would be this one, which is 0.2 value, right? This one is giving 0.2 because 1 minus 0.8 is 0.2. There you could see 0.9 is way too black. So here's what we can do. If you have a texture, which I'll add as a cloud texture that I have, this is actually available in the link. So you could see this is a packed texture. Packed texture basically is like you could have 3 different grayscale values in one single image instead of having 3 different grayscale images. So in the R channel there is this one, in the G there is this one, and in the B channel there is this one. So I'm using the texture which is available in the R channel like this. I'm going to do 0 because anything minus 0 is same, so no changes. If I do 0.1, you could see that there's more black spots because we did 0.1. So there are values and we just did minus 0.1 and it will basically give some values. If I do 0.5, there would be more black spots because we did minus 0.5. It is also good to do a saturate. What this does is that if the values go below 0 and if the values go above 1, it will basically just clamp it down to 0 to 1. It might not be needed for emissive, but when you are using for a let's say a lerp or something, like this one only takes 0 to 1, so you will need to do saturate, because if it goes 1 minus 1 or like 0 minus 1, then it would give minus 1. We don't want that. So a saturate node is really good. So you could see that if this values slowly increases, we can create like a fade out effect. So for that we could use a time node. It's not even possible to see quickly because the time goes like way too quick. So I'll just use a sine node, or actually a frac node. The frac node basically removes the right part. So this is just a way to test it out, okay? So what this frac node basically does is that, so this is the time node, okay? So this is what time node gives us. This node gives these values, but again we just need to do 0 to 1, right? Because if it's minus, if it gives like 2, 3, 4, then it's no point, because 0 minus 3, it's still going to give minus 3. So frac node basically removes this left part and it will basically loop from 0 to 1, 0 to 1, 0 to 1 like this. It removes the left part, so it always shows this one. So now it's basically looping, and you could see instead of giving it fade out effect, you're basically doing this stuff. So what this basically does is that when you subtract some values, whichever was the brightest one, which is like 1, would be the visible the furthest in the time, but whichever was like 0.5, 0.2 or something, it would go quicker because we are doing minus, and then it reaches 0 quicker. We could also do something like, if you use a radial gradient, which is looking like this, and then you subtract this from here, because this is 1 and this is 0 at the background. So you could see this is 0, this is 1. So if you now subtract, you would see we get some nice patches instead of doing multiplier, which you could understand in this stuff. It creates this nice patchy pattern, and then if you, let's say, do a panner or something which moves it up, you can get an effect like this because it is moving. Maybe the B channel one, because the B channel has like lots of black spots, so it looks better in my page. So I'll just turn this into an additive just to see. So it will basically add the color with the background. Let me just remove it. So you could say this is how it looks. Another thing that you could do is, if you use something like particle relative time, you could subtract it again from everything, or if you want you could just do it like this too, no problem. But because we are already creating an effect around here, we can do another subtract, like do this, add it to the saturation, This one basically gives the particle time in 0 to 1. So let's say a particle exists for 5 seconds, then it will give like how like 0 would be start and 1 would be end. And then if you use it in a, let's say, a system, empty system, let me add it, is to add an emitter minimal one, change the sprite texture to the one that I created, which is alpha erosion, like this. And basically let's do spawn rate of, I don't know, 50. This is how it's looking, but it's all facing at the same location. So maybe we do velocity at start, fix issue 100, spawn rate might be too much, so 100. Particle update, let's do shape location, so it spawns in like different areas like this. It should be in shape, sorry, in particle spawn, not in the update. And then maybe reduce this so that it doesn't go like this far. And you could see that instead of, maybe I remove the panning just so that we can see. You could see that as it goes up and up, maybe we don't connect it to the opacity. That's also creating a problem. Okay, you could see that how it disappears. Instead of fading it out, it is actually doing this stuff. So if you go in here and maybe set the size to be, I guess, 5 to 10, shape location to be like 10, or maybe 20 to 30. It would also be good to have the panning if you want more control over this subtract value, right? Because this one would always be same, so 0 to 1, and maybe you don't want this way, then you will need to use something called dynamic parameter, so that you would create a curve instead of this relative time and then just add it here. That would be too big for this stuff. Then if you just change the color to be something like, I don't know, red, wait, 50, it's not looking same because we need to multiply the particle color, because this one would basically get the particle color and then multiply this with whatever we have created. So it will take whatever is in particle and then multiply that color. And you could see that instead of it, you know, fading it out, it actually creates this fade out effect or the erosion effect. And it can be actually used, like the subtract can be actually used for a lot of different erosions. Maybe like on the wall side, if you want to show some rust erosion, or just want to create some mossy patterns and all, you could use this erosion one without having to animate. So yeah, that's all that is with erosion. Okay, because we are doing 1 minus these different values. So yeah, that's all.